Hello everyone. So in this session, you're going to discuss one more example for this proof by induction in binary tree. I'll show you the problem. So you're going to prove that a binary tree of height h has at most 2 to the power of k plus 1 minus 1 nodes. So in the last example that we have taken, we have proven that any binary tree of height h will have 2 power h number of leaves. Okay, so at the most, like at the most in the sense, like this is the expression, to the maximum of 2 power h leaf nodes will be there. So this problem we have discussed in the previous video with an example. So this session we are going to take, like this video, we are going to consider this problem, like we are going to prove that a binary tree of height h will have at the most of 2 power k plus 1 minus 1 nodes. What all nodes? Anything that has its, like all these things are nodes. Okay, all the round symbol, it might be either a root node or an internal node, or it might be even a leaf node. Okay, so you're going to count the number of nodes. That is the criteria. And how does an induction works? First, we'll be having a basic step. So basic step is handling the minimal input. So the minimal input over here is, here everything speaks on the basic of height. You're going to focus on a node with height, a binary tree with height k. So what happen if my k value is 0? That is the minimal input. If my height is 0, we'll be having only the root node. Okay, so we apply that in the formula. 2 power k value is 0 plus 1 minus 1. So that is 2 minus 1 equal to 1. So we have only one node and that is satisfied pakka. And what is your second step? Second step is inductive hypothesis. Hypothesis is we are going to have an assumption that till height of k, the nodes, the number of nodes that are present in the binary tree will be to the maximum of 2 power k plus 1 minus 1. So this is also proven. Now what is the next step? Inductive step. Inductive step is one where we are going to check for k plus 1 criteria. What might be the number of nodes that are present in a binary tree of k plus 1 criteria? So like here, like the height of the tree is the constraint. So we are going to consider a binary tree structure like this. Any height. So this is the last level. Okay. So according to that, like by leaving, like this is your k plus 1 height. Okay. So a leaf node, like any binary tree with the height of k, according to the second step, we know that it will have at the most of 2 power k plus 1 minus 1 number of nodes, right? And in k plus 1th level, that is the last level, what will be the number of leaf nodes? Any binary tree of h h level, h height will have 2 power h number of leaf nodes. Okay, so now what is the number of leaf nodes? The number of, like we are going to count the number of leaf nodes in the level of k plus 1. Using this formula, we can write it as 2 power k plus 1 number of leaves. Okay, so according to the criteria, like till kth level, my binary tree will be having 2 to the power of k plus 1 minus 1 number of nodes. And in the last level, that is k plus 1th level, a tree of k plus 1 height will have 2 power k plus 1 number of leaves node. So what will be the total number of nodes here? Like by adding these two, like you will be having 2 power k plus 1 minus 1 plus 2 power k plus 1 number of nodes. So this is the total number of nodes that is present in the final binary tree. Now you have 2 power 2 into k plus 1. So it is 2 into 2 power k plus 1 minus 1. So what is the result of it? It is equal to 2 power k plus 2 minus 1, right? 2. 2 into 2 to the power of something, you can add it as plus 1. Okay, it is k plus 2. K plus 2 minus 1. So this is the final formula for the actual finding. Okay, so we'll check what happened with your formula. So this is the formula, right? Your formula is 2 to the power of k plus 1 minus 1. This is a node, like the number of node that is present in a binary tree of height h. For height, sorry, for height k, for height k plus 1, it is 2 power k plus 1 plus 1 minus 1. That is k 2 to the power of k plus 2 minus 1. So this is satisfying. See, both the things are same. Okay, so with this, we can say that a binary tree of height k will have at the most of 2 power k plus 1 minus 1 number of nodes. Okay, so this is how we prove something using proof by induction method. Thank you.